All right, guys, let's talk a little bit about doing long division by hand. This is actually pretty simple. I'm going to show you a couple of things to hopefully learn and understand to make this go a little bit smoother. Now we're going to get I'm going to show you how to get the mixed number answer and also the decimal answer. They're not too far apart. They're pretty closely related. So let's go ahead and do it. So typical division problem is going to be written like this. I like to always rewrite a division problem as a fraction, because I always like to see the numerator and the denominator and find the top dog, which is what I'm going to show you here in a little bit. Okay, so make sure you remember that the first number written in a division problem, okay, the first number always goes on top, and the second number always goes on bottom. Doesn't matter which number is bigger or smaller, that's the way it always goes, okay? First number always goes on top, second number always goes on bottom. So let's do that. So this is going to be rewritten as the fraction 183 over 12. Okay, now from there, I like to always think top dog goes in the doghouse. Okay, so let's draw our doghouse. That's an arrow. Let's draw our doghouse. There's our doghouse. The top dog, okay, not necessarily the bigger number. It is in this case, but I'll do a video here. I don't know, probably not today, but sometime where the smaller number will be on top. Okay, the smaller number will be written first, and the bigger number second. You can have that too. Okay, but the top number always goes in the doghouse. So top dog always goes in the doghouse. Okay, and always show where the decimal point is in that number. Okay, so that's a whole number. There's no decimal point shown. Every number has a decimal point. If the decimal point's not shown, you assume it goes at the far right end. So there's both decimal points right there. Okay, show that decimal point and bring it straight up on top of your doghouse. Okay, and of course, by process of elimination, top dog goes in the doghouse. That means the bottom dog goes outside. That's an ugly 12. Sorry. We know it's a 12. All right, let's start dividing. Okay, take this whole number into the first number. 1 goes 0 times. Okay, pull your next digit in, the number 18. 12 goes into 18. 1 time. Okay, notice I'm always putting my answers on the doghouse above the last digit in the number that I'm taking 12 into. Okay, I'll say that again. Your answers go above the last digit of the number that you're taking 12 into. Okay, so I'm taking 12 into 1. The last digit of 1 is the 1. Answer goes above the 1. I'm taking 12 into the number 18. The last digit in the number 18 is 8, so my answer goes directly above the 8. Now, since I got a non-zero number up here, I got to go multiply back, okay, and subtract and figure out how many leftovers I have. So let's take 1 times 12, which is 12, and we subtract that from the number that I just took 12 into, which is the number 18. So 12 times 1 is 12, and then I subtract to see how many leftovers. So 8 minus 2 is 6, and 1 minus 1 is 0. Okay, now we need an answer above this 3 because we got an answer above the 6, but if I follow that 3 down, we don't have a digit here, right? So that helps remind us that we need to bring that 3 down, and now we have a last digit. Okay, so now we take 12 into the number 63, right? 12 into 63, and we follow that last digit up, and that's where our answer will go. Okay, so if you needed to go over to the side and do some doodling or whatever to figure out how many times 12 goes into 63, you can do that. Or even if you have a calculator, you can kind of add them up or multiply or whatever you need to do. And for the ease of things here, I just kind of know it in my head. 12 into 63 is going to go 5 times. So I follow that last digit up. Okay, non-zero number. We need to go multiply that back by 12 and subtract it from the number we just took it into to see how many leftovers we got. I'm going to slide that up. 5 times 12 is 60. We subtract. Okay, now I like to always think of this decimal point as kind of our wall. I call this our decimal wall. Okay, when we hit our decimal point, we can stop, and any numbers that are left over up against this decimal wall, these will be our remainders. Okay, so we have an answer of 15 remainder 3. So if we build that into a mixed number, it's going to be 15. Remainder always goes on top, and 3. And twelfths, your same denominator always stays the same. Okay, so we get 15 and 3/12, which actually simplifies to 15 and 1 over 4. So that's a good mixed number answer. Okay, now if we wanted to go on to find our decimal answer, that's when we work on past our decimal wall. Okay, so we don't have any digits over here, but remember we can always add zeros to the end of our numbers. So we can add a 0 here. Now we can bring it down. Now we can take 12 into 30. The last digit of 30 is this 0. Follow it up. That's where our answer will go. Okay, so now we need to take 12 into 30, which will go 2 times without going over. Hey, that's a nicer looking 2 there. 2 times 12 is 24. Kind of imagine this wall is not here now. We're going to subtract. We got to take 30 minus our 24. By the time I borrow, right, make that a 10. 10 minus 4 is 6. And I borrowed, that's 2 minus 2 is 0. We get 6. And we got to keep going here until we either establish a pattern or we end up with no leftovers. Okay, so let's add another 0. That gives us another digit here. Now we can take 12 into 60 this time. So if we take 12 into 60, that's going to go 5 times. Follow that last digit up 5 times exactly. And 5 times 12 gives us 60. And finally, we get 0 leftovers. And that's when we know we can stop. We now have a terminating decimal, right? So 15 and 1/4 is also the same thing as 15.25. And those would be our 2 nice, simplest form answers, right? So long division is really not that bad, okay? So we can either stop when we hit our decimal wall. Any numbers left over here, that'll be our remainder. Now, if we want to keep working to get our decimal answer, we just work on past that decimal wall. And usually we'll have to add some zeros if we need them. We can keep adding zeros as many as we need, really, until we get a remainder, until we get a terminating decimal, or we might figure out that we have a repeating decimal. And at that point, we could put some sort of repeating bar above our answer if needed. But that is a good example of long division with a terminating decimal. So there you go. Hope that helps.